Okay, we last talked about arithmetic sequences, and where we were taking a first term and adding or subtracting the same amount each time to get the next term. Next type of sequence we're going to talk about are called geometric sequences. Okay? So again, you can pause to copy this down if you like. Geometric sequence is one in which each term is equal to the preceding term multiplied by some constant. So let's take a look at this first example that I have. 2, 6, 18, 15, 54, 162. Okay, it might be fairly obvious to see, but if not, you can figure out that if you go 6 divided by 2 gives you 3. Okay, so in order to get 6, I'd multiply 2 by 3. If you multiply 6 by 3, again, you get 18. Okay, so it looks like we're multiplying each term by 3 to get the next. Okay? That is known as the common ratio. Okay? And we'll represent it by R. So again, what we're going to want is a recursive formula and an explicit formula for this. Okay, for the recursive formula, again, we tell the person what that first term is. Okay, so in this case, I have T1 is equal to 2. There it is. Now, to get any successive term, T to the n is equal to that previous term. This time, instead of adding a certain amount, we're multiplying by a certain amount each time. So you're taking the previous term and multiplying it by 3. And so there it is, a recursive formula. Not much different than an arithmetic. For the explicit formula, again, it's going to be T to the n equals, and the general formula for this one, and you'll be able to quickly work it out, is again A, that first term, this time times the common ratio, or the amount that we're multiplying by each time, to the power of n minus 1. So for this particular example, T to the n equals, our first term is 2. So it's 2 times, my common ratio here, R, is 3. That's what I had to multiply each term by to get the next, to the power of n minus 1. And you can quickly see if that works or not. Let's take the third term in this sequence. So our third term is 18. So we fill that into our explicit, equals 2 times 3 to the power of my third term, so it's 3 minus 1. So T3 is equal to 2 times 3 to the power of 2. Okay. 3 squared is 9. 9 times 2 is 18. Okay, so there you can see over here, our third term, first, second, third, is indeed 18, so it works. All right, we'll switch over to the next board and give you another example. Okay, here's our second example, and again, what I'm going to want is a recursive explicit formula. And for the recursive, we're going to tell them that that first term 64. Now, to get the common ratio, or R, if you remember from the previous example, what we did is we took the term ahead and divided it by the previous term. Okay. So, what I have to do here is go 32 divided by 64. If you do that, you'll end up with that it's 1/2. Okay. 16 divided by 32 gives you 1/2. So my common ratio here, R, is equal to 1/2. So now I've got the first term is 64. I tell the person to get any term, you take the term before it. Get any term, you take the term before it, and multiply it by our common ratio, which is 1/2. For the explicit formula, t to the n. Okay, again, I'm going to write down the general formula, a times common ratio to the power of n minus 1. So for our particular example, a, the first term, is 64 times the common ratio up here, which is 1/2. And I'm going to put that in brackets to the power of n minus 1. Because I don't want just the 1 to the power of n minus 1, I want the whole 1/2 to the power of n minus 1. So there's our explicit formula.